Go live button. Yeah, we're live.
Excellent. I'll start talking then. So hi and welcome to Armakuni Friday Teaming. This is episode 11. Can't believe we've been going that long already. I'm here with John and Ben, and today we've decided to change things up slightly. Instead of our usual code katas, which are kind of designed for kind of practicing your TDD, we thought we would try a Leetcode challenge. So we are going to try the dungeon game challenge today. I think this was John's suggestion. We went through a few different challenges to find one we like the look of. This one looks fun. So what we have to do is the demons have captured the princess and imprisoned her in the bottom right corner of a dungeon. The dungeon. Oh, excellent timing. I'll just read the markdown. Where was I? Bottom right corner of the dungeon. Thank you. The dungeon consists of M by X rooms laid out in a 2D grid. Our valiant knight has initially positioned in the top left room and must fight his way through the dungeon to rescue the princess. The knight has an initial health point represented by a positive integer. If at any point the health point drops below 0, our knight will die. Some of the rooms are guarded by demons, represented by negative integers, so the knight loses health upon entering these rooms. The other rooms are either empty, represented as a 0, or contain magic orbs that increases the knight's health, represented as positive integers. To reach a princess as quickly as possible, the knight decides to only move rightwards and downwards in each step. Okay, so we basically have to maneuver our way through this 2D grid to get to the princess in the bottom right corner from the top left corner without losing all of our health by being intercepted by the demons, and hopefully increasing our health by hitting some orbs. Okay.
So is there a visualization of it on the streamed version? Because I don't see, I only see the non-rendered markup.
So there is, hang on.
It shows the grid, okay.
Yeah, it shows the grid. For some reason, the markup display version keeps dying for me, but yes, so there is a grid. Ben, it might be worth if you can, like, I send you a link.
Do the preview. Yeah.
Yeah.
Actually, can I do preview in
No, doesn't work.
I can't do preview in code with me, which is a bit the same. But I mean, I can add a quick. Let me just add a quick window over here.
So the link to the thing, yeah.
Yeah. Dungeon problem, wherever that is.
Hold on 1 second. All right, so that's what it looks like for those watching on the stream. Just resize this and put it down in the bottom corner, just for reference. I can always turn it off later.
Yeah, we need it for our own reference when working it out.
I mean, you guys, like there is a link in the README that you guys can have a look at, right? So just
yeah. Cool.
I would like to suggest that we do try to TDD problem.
I think
so
we should.
I'm still trying to understand the problem.
But for a test, Ben, there's an example already. There's an input and an output, and we can just stick that in the test.
Yeah, sure.
So that's our first outside-in test. for this input, you need to get that output.
So if we go...
What do you think, Mark?
So what we need to do is calculate the minimum health points needed to maneuver to the princess, basically.
I mean,
so do we need to...
That's the ultimate output, but there are many stages in between that are complex.
Yeah, and so I'm still trying to understand fully what do the numbers on the grid represent again?
So positive numbers represent a room with a magic orb where we gain health points. Okay.
Right.
And negative numbers are demons that will take our health points, and 0 is an empty room. So if we step into an empty room, it's fine. If that makes sense. It's all safe. And what we need to calculate is the minimum number of health points we would need to maneuver to the princess.
I just realized, Ben, I think it's another graph problem with...
Oh yeah, this is a graph problem.
The edges of the positive edges are added on, negative edges are subtracted.
I mean, it's basically breadth first search, isn't it? Kind of. But I'm trying to understand. So from that example, why is the minimum health 7? Oh, because right. Okay. So either way you go, so whether you go right and then down versus down and then right, you still need the same number of health points. I'm just looking at the example image.
So you start, so you need you need at least 2 to step into the dungeon, because you're going to lose 2 immediately.
Yeah, and
then you're going to lose 3, so that's 5. Then you're going to gain 3, gain 1, and then lose 3 to actually rescue the princess in the final.
But if you take the other route, you start by losing 5, and then you lose 10, and then you come out with minus health points.
Yeah.
Well, no, because so if you go down the first column, so -2, -5, and then +10, 30, +30, then -5. The first 2 rooms, or you're still losing 7.
Yeah.
So okay.
But the last 2, you're gaining enough to reach it. So.
But you still need 7 to get to that 10.
Okay. So what? Yeah. All right. Fine. I get it. I get it now. I get what.
Why do you need 7 to get to that 10?
Because you'd lose 2 to be in the top left square. Then you go down to the -5. That'd be you'd lost 7.
Yeah.
And then you're in the 10, and then you're in a positive number, but you've still already lost 7 health points at that point.
Yeah.
So you lose 7. You lose 7 health points whether you go down, down, right, right, or right, right, down, down. It's the same number. So either of those paths are the best paths, because they're equal health point risk.
Yeah. Makes sense. Okay.
Yeah.
So, I mean, this to me looks like a graph problem.
Yep.
And you do breadth first, right? Because like, how would you'd want to? Yeah, you basically, because like so there's 2 problems here, right? Like you need to find the optimal path, and then but the way you find the optimal path is basically the lowest. So it's not like the sum of the numbers; it's the minimum, right, of the count. So as at each step, we need to store like the current damage, let's call it, that the knight has taken. And then whatever the minimum of that is like so, and then you find each path to the end, and then whatever the minimum of that is, um, will be the health that the knight needs to start with.
Yeah.
Isn't there is a set of known algorithms from graph theory, like Dijkstra or whatever his name is.
Dijkstra.
Dijkstra.
So how are we
Yeah,
gonna?
but the problem, like, would
Yeah,
Dijkstra's help here?
shortest
So,
path.
like, because this isn't technically a shortest path problem, is it? It's
There's a constraint. You can only move right and down as well.
yeah, that's fine. So that just means it's directed graph. But I'm just trying to think, like, so
Why isn't it shortest path then? Or constrained
because it's not
shortest path?
the like you're not. So okay, you could represent the like each of the numbers as edges, right? And then like so to get short to if you wanted to do Dijkstra's on it, you'd have to set up a graph where the edges are the weights, right?
The edges are the room values.
Yeah, the edges are the room values, and then but then shortest path would imply that you'd want the sum. You're looking for the sum of those values to be as low as possible, or maximize it, whatever. But that's not.
That's true.
But
Yeah.
that's not the the problem. The problem is you have to find the minimum. So like the sum. So like the optimal path could still have a sum that is higher, but a minimum that is lower. If that makes sense.
Yeah.
Yeah. So at each point you need to
Yeah.
check
So it's kind of
you've got the real minimum.
yeah. I mean, it's a graph traversal problem where we visit each. I mean, okay, the brute force solution to this, right, is like you each you find each potential path through the grid, right? And then you keep a minimum counter, right? Of like what's the current minimum, and then every time and so you keep the sum and the minimum, and then every time the sum drops below the minimum, you update your minimum, and then keep going, and then. But I feel like the brute for like, especially with a dungeon that's very big, you're gonna have quite a lot of that's gonna be computationally very expensive. So I feel like you'd have to do something that's a bit opportunistic as well, right? So like you
You could take a first path, and then could you do it where if you suddenly go over, you kill that looking?
yeah.
You know,
So that would be like you'd implement some kind of early stopping, right? So maybe
yeah.
actually it's more like a depth first search problem.
Where would be why
Yeah.
why would you be stopping early?
Because if you find another route that's, I don't know, it takes 7 health as in this case, and you find another route as soon as it hits 8, you immediately stop
Yeah, because you
searching.
already
No,
know that that's not
that's
the
fine. Yeah,
optimal
of
route. Like
course.
that means
Yes.
you've already found a better one.
We're trying to always
Right.
find the minimum. It doesn't matter because we're not trying to find like the cumulative points. We're just trying to find the minimum
Yeah.
points. You know, if you go over that, say 7, it's
Yeah.
immediately worse. But that's yeah.
So
I feel like we should probably like diagram this out first before we try to attempt to solve it.
Yeah.
Okay.
How? Yeah, absolutely.
Have you got a diagramming tool to go with? What do you want to do?
We could just open up a mirror board for
So is there something like you do the first one? What would the first one be? You could go just right.
So I was wondering, like, so John was saying, should we just test drive this? Like,
Well,
is
I was suggesting that we just put one outside in test that we can
okay.
continuously
Oh,
run.
not build up
Because-
kind of our understanding, like basically having like a 2x2 grid with all zeros, so you have to start like with one and then
We
add
could.
to the complexity.
But my intuition tells me that because it's an algorithmic problem, we will get ourselves into a mess with TDD.
Yeah, I mean, it's a Leetcode problem, right? So I don't think
Yeah.
I don't.
But an
think-
outside-in test using the example,
I mean, yeah, but like that's how
right?
that
It's-
sure, but that is the just draw the rest of the L, right? Like I don't. Yes, that is what we're going to be doing. If so, like you can set that up as the test case, but then in the end, like what? It's just going to be, oh yeah, return 7. Okay, cool. Then what's the next test case?
That's why I
Well,
wondered if we
you're
kind of
right.
did.
That's a good point. Maybe we should start with a simpler test case.
I mean, I wouldn't try to TDD this, really.
Okay.
Or maybe we should sketch it out first
Yeah,
and
that's
then
what I would
think
do.
about test
Okay.
driving.
Do you want to share a mirror link then?
Because
Yeah. Give your board a
I
time.
feel that once we have an idea what we're doing, we should test drive it. And
Yeah.
it'd be a good reflection on how TDD can be combined with algorithmic problems.
I mean, is the answer to that quite difficult?
Well, maybe even pointless. Because it's, algorithmic problems usually have a sort of mathematical solution with a formula, and that's something you need to arrive at by just thinking abstractly using intuition.
Yeah. Do you want me to set up a mirror board, or are you doing that?
I'm
No,
in the
I've
mirror
already,
board.
I've already shared the link. Right. Cool. Got it on the stream as well.
Okay, sorry, I missed it.
All right. So let's just I'm gonna copy that.
Everyone, John, Mark, did you get the mirror board link? It's in Friday Teaming.
Yeah, I just missed it. I'm just joining it now.
So
So that's our dungeon grid example.
Yep.
Yeah.
Yeah, so I guess imagine if you start here, and then I don't know, like it could just be, yeah, depth first search. So you start with, the rightmost.
So you're tracking the sum during the whole traversal.
So
Yeah,
you're suggesting first off walk all the way to the right, then down would be the first.
yeah.
Path
So
you're
you
gonna
walk,
check.
so you walk all the way right and then to the down, right? So you have to establish a baseline, I think, right? So like you
Yeah.
can't. So you have to. I think it has to be depth first, right, to start with, right? So you get your first, right? That's the baseline, and then for the sake of argument, then you get. So what is that? Like so at each step, right? So let's say here the min is -2, right? And then it's -5.
Yep.
Then we're back at -2, right? But so if we're keeping track of the min, it's still -5. Still -5. But so we need to keep track of the two numbers, right?
So you need to track both.
Yeah, so it's -2, -5, 1, -5.
It's 2 there, and then it's what?
Sorry, here 5, 1, and then over here it's.
But it depends? What's the initial health of a knight?
There is no initial
That's
health.
what you've got. There is no. You've got to calculate what the initial health should be, the minimum.
Yeah.
Okay.
Oh, I see. Yeah, right.
So because this then goes to -4, the minimum is still -5, right? And then another -3, so -7. So then you update it, so your minimum is -7, right? So
Wait, why is it -7?
because it's 3 health to go to the princess, right?
So -5. I thought it would just be -5. Have I got this completely?
No, but then you got +3 is -2.
As you go from -5, then you add 4, so you go to -1, and then you end up, then you take away 5?
No, so it's -2, -3, then you add 3, so but you're like on -2.
Yeah.
Then
you add 1.
I should have done this in different colors, right? Then add 1, then you're on sorry, -1. Yep.
-1.
-1.
-5, so you're on -6.
-6, yeah.
So this is the optimal route because the other one is
why is it saying 7? Sorry, we've got something wrong in our math.
Maybe you have to be positive health. That's weird.
Yes. So you're starting you can't start on 0 because you're dead. So you'd have to start on 1.
Oh, so it's
you need
minimum.
to add
So
one,
it's minimum plus 1.
Yeah.
Okay, right.
Okay.
So that's your. Yeah, fair enough. So -6. So you take away. So you take away -1 from the final thing to get your starting health. Yeah, but that I don't think that really matters in the end of the day, right?
Yeah, no. So but what that does mean is that in this
But
case,
that's the output.
Yeah, that'll be the output. But the point is for finding the shortest path, that +1 doesn't matter at the end.
Yeah, no, I agree. But what that means is downwards. Just in this example, -2, -5 is not the optimal path because you're already at -7.
Yeah, exactly. Right. Yeah. So that's what I'm saying. So I think what we do is we just say, right, go all the way to the right. So you do a baseline, you go all the way to the right and then all the way down, right? And then that's your baseline, right? And then you start searching the other routes. And then as soon as you hit a point where your minimum is greater than the previous route's current minimum, then you just stop and you go back, right? So you backtrack.
Yes.
Yeah. And look for another.
And so
why
search for
why
another
is
route.
The baseline all the way to the right and down?
I mean, we can do all the way down and then all the way to the right. I suppose it.
Oh, you mean
matter.
that was arbitrary?
Yeah.
Yeah. We just need a baseline.
Because the thing is, you can't at each point, you can't. Well, I suppose you could make a decision at each point, right? But you still need the baseline. Say what the.
Yeah, I think you need a baseline so you can do the early termination rather than say trying to calculate every single one all the way to the end. Which, if it's a big grid, is going to be. Well, it's going to take a long time.
Yeah.
I'm just to put it out there. There's early termination is an option. Do you want to go for full termination of just start the path again? So say we've got our baseline of 7, and then we hit a route. So say we do the next one would be just 1 to the right, then all the way down, and then over to the right again or something, and that hits 8. You could just step back a step when you go beyond, or we could start the whole route again. Obviously, there's more complexity. Does that make sense?
Doesn't that waste computation?
Probably.
This is actually I just realized this is a binary tree because at each step you can only go. It's not. It's a simpler. it's not a full graph problem. It's just it's a tree, because each one you can only go right or down, right? So
Can you draw
if you represented this as a tree, so what you'd have, -2 at the top, right? That's your node, and then -3, -5, right? So this is kind of how you've got your tree structure in here.
Yeah.
And then it's
-10 and 3.
yeah. So it's pretty much, I would say, depth first search with some kind of early termination, right? So you just say, right, let's go all the way down the right hand side of the tree.
Yeah.
Yeah. So rather than making this well, I don't know.
Grid.
We could do it, like redo this into a tree structure.
It's I mean, not this is. Is it still technically a binary tree if from 3, the only actual option is to go 1 then 5?
Yeah, it just
Because you
means
only go
that
right
each
or
one,
left.
like each it
Because
only has
those
it
are
only
the
has
slots.
one
Yeah.
child, if that makes sense.
Yeah, it has
Yeah.
one child. That's right.
I just don't remember the
Whereas
definition.
if you're on the middle square, you can go to 1 or to 30.
Yes.
Yeah.
With the 2
Although
nodes coming
actually
out
no,
of
hang on, I'm wrong. That's because nodes can have so no, it's not a tree because nodes can have multiple parents. So it's a graph problem.
nodes can have.
What does -10 can go?
Oh, because one can have. Right.
Yeah, because you have this 30 and then
But you
5
can
like that. So that's
you
not
can
a tree
only
anymore.
move.
Okay, it's a directed graph though, isn't it?
Yeah. But because you could do this, for example, right?
Yes.
So it is a graph.
Yeah.
So it's not a okay. It's a simple. You're always going to have at most 2, which is
So it really is a directed graph shortest path. Oh, except that we're looking for the minimum, right? Sorry.
Yeah.
So in the case of this, our graph would do. Let's say we did the right hand first. We start going down, say the left. It goes -2, gets to -5. Realizes it's already at -7. Early terminates.
Yeah, exactly. But you still build that baseline by just going like go all the way to the right, go all the way down, right? Then that's your baseline, or whatever. And then you start. Then you. I mean, what you could do, I guess, is backtrack, right? So you just say, fine, okay, we finished. That's our number. Go back one, go back up, and then go down the next path instead, right? And then early terminate if you get to a point where it's like, the minimum gets smaller, right? And then what you do is you keep a list or a set of nodes,
Hang on.
right, which represent
No.
your ideal path. Actually, we don't even need to do that, do we? Because the output needs to just be the minimum. So I think that's it.
Yeah.
Isn't it?
I feel we haven't been keeping
if
character
you-
Leetcode though. So anyone want to do? What's the big O of this going to be? Bro.
I mean, because you're basically going to be going down almost every path, but with early termination.
Same as shortest path, which does that.
Just because we want to do this in a Leetcode fashion, so
maybe
Well,
let's not worry about that. Let's not worry about that
let's
for
get
now,
some
right?
code
Because this is a difficult
Okay.
algorithm.
So apparently Dijkstra's algorithm gives you O v squared.
Where v is what, the number of nodes.
V is
You can hear my dog dreaming in the background.
But anyway, look, I mean, if it's, we need to find the shortest path as the first stage, right?
Yeah.
And then if we get that path as a list of numbers, we find the minimum where it hits the minimum.
Yeah.
So we can use, we don't need to rewrite Dijkstra's algorithm. There's a library that does it for you and returns the path as a list.
So Dijkstra
It's
is
a solved problem. That's what I'm saying. Like in a sense.
yeah, but then you need to set it up so it's the edges, right?
Yes, you need to build a directed graph.
Because the way Dijkstra's works is you have a list of edges, right? And then you pick a start and an end point. And then you sort the edges by like shortest to highest, and then I think you just keep on taking the shortest edge. Anyway, I don't know if that will work because you have to make the decision at each point in like in your traversal, right, as you're going through it.
What if you stop early?
Yeah.
Could we start? Just trying to think. I mean, breaking down the problem, first thing we need to do is do the, like, could we not do it so we pass in a grid where it's like 0, like 2 by 2, top row is 0, 0, next one is -10, 0. We expect 1 back, and just like start by understanding, like, because obviously we confused ourselves almost immediately when we when we started doing the calculations of what the math should be like to work out whether the minimum health is right. So could we get that working, and then once we know that we can do the maths right, then go to solving the next problem of we need to traverse all of these paths and stuff. Does that make sense? Just trying to break down the problem.
Yeah, fine. That sounds.
It's not getting into the meat of the problem, because we'll just get it to do all the way along the right and down. And if we put a big enough number in that first down, then those tests would always pass, and we know we've solved that problem.
Sure. That sounds like a good idea.
And then we just change it up so that actually the next path is, we just switch the numbers. Hang on. Bottom left with top right. And then we can start building the algorithm to do the checking the paths. Or have I massively oversimplified it? Please shout if I have.
No, I think it's a good place to start.
Should we just start trying to get some code down and then?
Yeah.
Yeah, let's do it. Right,
Okay.
Who wants to drive?
I'll drive.
Cool.
So are we writing this test first? Let's see you start it, Mark.
Yeah, let's do that. So hang on. I think if you just change line 9 to be 2, no, you need to make I'm not sure if that should be a 2 by 2. I think array.
You're doing a make int 3 here.
Yeah. I literally just made something so that I had a test that was ready. So that Like ignore
Okay.
it. Like it's just
But shall we put some inputs into it?
Yeah.
Like from the actual example?
Yeah, so take that.
Does it work? Just copy it. Can you do that directly in the make, or is that just?
I don't think you need to make it. I think you just do A equals A walrus, and then the dungeon.
A equals A.
And then just
What?
paste
No, A doesn't exist.
just paste the array. Yeah.
Oh, just that.
Yeah.
Right. Okay. Oh yeah.
And then assert equal that 7. Calculate minimum HPA. Yeah.
Yeah. A. Yeah. Why is that squiggly?
Don't know.
It's complaining about A is not used, but it definitely is.
No, there's some other problem here. I don't think there's something wrong with this array notation. It says new line or curly bracket expected.
Oh, sorry, you have to do it like this. So,
Missing.
And then these have to be squirrely braces. I miss not having Vim in code with me.
I'll do it. Should I do it?
Yeah, go for it.
That's a hang on. Square brace goes away. That's it. Yeah, and you're missing a comma on 11.
Yeah.
Cool.
Oh, copy. It says unused variable A. Why is that?
You just need to save it.
No. Try to run the test and see what happens.
Or does assert? I mean, assert is complaining. Assert unexpected.
Yeah. Oh, some too many curly brackets here. Here we go. And now calculate minimum HP. Do you want to run it first and see it complain about the function not being there?
Yeah.
No, the function's there.
It's not finding it.
No, I know. I'm not quite sure what's happening. Oh, there's a, hang on. Okay. Rerunning it.
Thank you. Cannot use A as type 3 int. Oh, because that's not how you're defining it.
That limits us to being a 3x3.
Yeah, we need a.
Right, I'm trying to run the test now. I don't think it worked.
Yes, so it's now saying, can you see the test on your screen, Ben?
I don't see it.
Okay, so we run it in the terminal then. So
I would run it in the terminal, yeah, because it's not coming up.
Cool. Okay.
There you go. I had it. Hang on. Go. There you go.
Thanks. Oh, okay. Fine. So
Mic off, mic on.
Yeah, but we want it to be able to take it like any sized array, right? So
True. So, how do you represent that?
Looking up, I haven't done that in a while.
I mean, do you not just take the numbers out?
No,
Like that.
it's lint. Ah, I see what you mean, like that. You can
That's
match. So.
So there you go. So don't put the numbers in either side, then it matches.
Okay. Ah, yeah.
Cool.
You're right.
So we've gone for return 7.
Cool.
Should we not?
We've done it, guys.
Way done. Excellent.
Shall we submit?
So I feel like, I mean, we need a, if we, like, this is what I said, if you TDD this, there's only one example, right? So we'd either have to come up with our own example, which I would rather not spend time doing that.
Of course.
Right.
But the
So I wondered if we build up the algorithm that does the calculations though, through test.
Yeah.
That makes-
So what would the next?
Just so well, I would have
we would
suggested
test something else, right? We wouldn't test the calculate minimum HP. Test like something in the algorithm.
So I wondered if we did something where all of the. So can I just draw out a test?
Yep.
That's probably the easiest thing. It's something like this, yeah. So kill this line off. This is 0,0. No, not 0. But the expectation on that grid, okay, would be 1, because you need a single health point to go here and here and here, like that. Like, and just build up our complexity of literally understanding the health points we need. Going, you know, there, and then we can, like, next test you could do -1, so that you'd need 2, so that we know that we're calculating the health points correctly.
Yep.
And
Okay.
then once we understand how we're doing that bit,
Yeah.
then we can go and actually start doing the path looking.
Yeah. Okay.
So can I comment the top holding test out for a second, because that could be maybe like our 3rd or 4th test.
Okay, so do you want to change that back to 0?
So
Yep.
Which one? This.
So if we run that, okay. So then we can go to 1 and do your hard coding. That will pass that. And the next test would be we can do just 1. So now we need at least 2 health points.
Yep.
And now we can start like
We need
and
to rename them.
avoiding like TDD. Let's just start writing how we work that out.
Yep. Okay.
So, or do you want? So you like, or do we want to turn it into like? So, do we at this point just want to like turn this into? Because at the moment we've got a square of like the
I think we
array.
want to keep this conted out, because we've got to keep
Yeah.
that. I think well, why don't we just start with do the right then downward path?
Yeah. So I suppose my question is, how are we gonna? Are we just going to calculate all the possible paths, or are we going to transfer this into something different inside our function? If that makes sense. Are we going to keep the square, the 2D array, or is that going to be like? Is there an easier, better way to move
I
that
think
around
we
it?
would. Yeah. Once we understand this part, we would
I think
start
keep it as
driving a more internal function, a more specific thing.
so data structure wise, I would keep it as a 2D array. I don't think we need to turn it into like a like a B tree or anything like that, because we've already got the array there.
But for now, how about we just traverse all the way right and down?
Yeah.
So
And expect that to be
what
2.
do we do? Dungeon.
So
Sorry.
start with like a loop. But
I'm supposed to be driving, aren't I?
yeah.
So
Sorry. It was I was just demoing something. So do we want to start just like with loops to do it?
So we could start with the
we wanna
function called
traverse-
get baseline, right?
Yeah, that sounds like a good plan.
So maybe that's what we're testing for, we'll do get baseline, right?
Yeah.
Given your
given the dungeon.
Okay.
And that also returns an int. Why is it complaining? Oh, because we're missing returning something.
Yeah.
We want to write a test. Forget baseline.
Why don't we just do return in calculate minimum health points, just return get baseline?
Yeah.
Now.
That's what I would do. So instead of returning 1 from that initial function on line 5, say return get baseline dungeon.
Sorry?
So line,
I see.
So line yeah.
Yeah.
And then you got to pass dungeon into that. Yeah. And then so now what we want is so like loop through each.
Yeah. So remind me how I do this and go. It's not form, is it? It's range.
No, it's wrong place. Sorry. Okay. Like that. So we can just use for loop, and you can do.
Oh, okay, right.
You could take like the length of the 0. Hang on.
First row.
Yeah. Yeah. So you could do something like dungeon 0 dot length. For the no here.
Oh, for the limit.
That just takes you over to the...
Yes. Yeah. Well, no, then we're only iterating the first row, right?
Yeah.
Yeah, that's what we need to do
so
first.
We need 2 for loops, right? First for loop is to go along the first row, and then once we get to the end of the row, right? So you keep a minimum, right? And then you do the second for loop once you get to the end, which goes down the last column.
Are we? We're not keeping track of the total, right?
No, but we should, right? So
yeah.
So we'll need we need a min and a current health. So I would instantiate those 2 above the for loop, right? Call it min health and current health.
Like I'm in a coding test.
You could. Thing is, it's going to be total +1, isn't it?
Yes.
No, it's not.
No, it'd be min health +1.
Right.
But,
yeah.
So I wouldn't call it total. I would call it current health.
Yeah.
Oh, I see what you mean. Yeah.
Right. Okay. Accumulated health points.
Yeah. And then so for each one, right, what we do is, and the logic's going to be exactly the same.
So current health, we're just adding
Yeah, plus
We're doing
equals
plus equals
dungeon I. Oh, sorry, dungeon 0 I.
Yeah, dungeon. Yeah.
right. Okay, first row.
Yeah. And then min health is I would maybe initialize at like 9,000 or something like that, right? Yeah.
What? Why?
Oh no, sorry, hang on.
Why not just do something like if current health is
Oh yeah, if current health is less than min health, then min health equals current health. Yeah.
yeah.
Well, yeah,
Yeah,
this
and
is
but that's why you need to
standard
instantiate it at some high number, right? Because both of these are going to be. I suppose if both of these are going to be negative, then yeah, why not?
Sorry,
I mean, if you
oh, wait a minute. If current health
Yeah,
is less than min,
so because they're always going to
um,
be. So
yeah,
yeah, well,
so
probably don't need to
min health.
start at 0 then. It's, at 9,000, you could just start at 0 because they're
Yeah.
always going to be negative, and then you just say min health equals current health. Yeah. Yeah, and then do exactly the same loop,
Yeah,
except the
we're going down the column.
yeah
last
the length
column.
condition is going
Yeah.
to be different, right? So
So could we, instead of using,
here it's just going to be len dungeon, I think.
yeah,
Len dungeon -1 because we've already done the first entry in the column because that's the last one on the first row.
Oh, you're right. So
Correct.
we don't need to
Correct.
include that, do we?
Correct. Yeah. Well done.
It's, I mean,
Yeah.
it's always a
could
square,
you not
isn't
start
it?
at 1 rather than starting at 0?
It's not always a square. It's an m by n.
Ah, okay. So it
Wait,
has to
what?
be.
But it'll still be -1 because you've already done the first one, though.
Yeah.
Yeah, so what I'm suggesting is you could make the
So just
initial
Len Dungeon then.
number 1.
You have to do the -1 outside of the
Well, no,
len.
hang on. No, so you're right. It's not. Don't do the one. Just make the initial 1 because it's still you're still looping
okay.
through the
Then-
because
then it does that step.
the index still matters, right? So we still
Yeah,
need we're
okay,
just
yeah,
starting
no,
from
right.
we're just starting from the first index point.
That's a good point. Yeah, that's a nice way of doing that. Definitely.
But you don't want to add the last, like the top right corner again, do you?
Yeah, and we won't. That's fine.
No, that's why you make I 1 in online 19.
Yeah.
So the first part of the thought, that's it, yeah. So
we
then
skip it.
you would immediately have stepped
Yeah,
down.
yeah.
Yeah.
So
And then this
now
becomes
this is not.
I, and then the last element.
Yeah.
Is there a shorthand way of?
Can we do -1 and go?
Yeah. So it wouldn't be, yeah.
Can you? Is that a thing?
Not
don't know.
sure. No, you'd probably have to do.
That's what we want to do.
Yeah. Well, I mean, you want this basically, right? So.
This -1.
Yeah, I mean that would work if you can't just do last or something and go. I find that easier to read personally, but
Is there a last?
No, there isn't.
I mean,
You
there's a
have
way
to
of
do
doing
this
it, no.
len of the thing -1.
Yeah.
fine.
Yeah.
So that should work.
And then we want to return min health. So let's
Is
see.
it camel case in Go?
probably.
Mark, remind me. Like,
Yeah, it says use camel case instead of snake case.
it is. Yeah.
I mean, single letter variables. Come on.
Oh, of course. Yeah.
I'm joking.
We
Why
can
am I? Why was I
just leave
thinking
that.
I don't think it
Something-
matters. Like, let's just
No.
and then let's return.
Yeah.
Let's return min health.
Yep.
Sorry, I was thinking about something else.
Do we not need the if as well?
Yeah, we still need the if.
Yeah, right.
Yeah.
So that will be tracking a min health point, and that's what we return.
Yeah. So let's
If
run the
current
test
health-
and see if it passes.
If current health
Yes.
stays 0, oh, it will just stay at 0, won't it? Yeah, so it doesn't matter. We can just have to 0. Ooh.
Expected 2 got -1. So you need to, because that's the thing, yeah. So we're calculating down, but we need to.
Yeah. So you have to do return minus min health plus 1.
Why?
Well, because your minimum because the minimum health is always
You're looking
negative,
for a
right? It goes
positive
down.
number.
So you need to change that to a positive number, and you need at least 1 HP.
Can you just stick a minus?
Yeah,
There you go.
that passed.
So it's all passing. So if we uncomment that original test, that should also pass because that's technically the baseline is the shortest path.
That's
Very exciting.
Yeah.
Yeah,
Okay.
cool.
So we got the baseline down.
I'd like
Yes,
to
nice.
point out that we've written a heck of a lot of code for one test.
Well,
Yeah.
but this is where the TDD stuff breaks down.
Yeah. I wouldn't.
Yeah.
I don't think we
But we-
should
No, I'm just
hardcore
saying.
Yeah.
this because it's an algorithms problem. So
Yeah. So,
It's a
but I
bit-
think it gives us a bit of.
It's AK saying stuff against TDD.
Well, I think this is kind of the issue that a lot of coding challenges on things like Leetcode are algorithmic.
Yeah.
They don't lend themselves well to testing because it either works or it doesn't.
Yeah, I totally agree. I totally agree.
And then I think the actual Leetcode tests are often things like you can have a timeout limit and memory things. So it's more like, is this an efficient way of doing it rather than a
So the next so okay, right. So now in our main function, I think what we need to do then is I mean, okay, how about now we make up a test where it's the baseline is not the shortest path, right? And then that's our test case for actually, implementing the algorithm.
Can I do that? Why don't we just swap?
We not want to refactor any of this code and say
I don't think there's
no.
anything to refactor here.
Not yet. No, there might be later.
I've swapped the -5 and the -1, so
Okay.
that should now be failing.
Yes.
Yeah.
Yeah.
Cool.
So.
right. So now we
Now's
are
the hard part.
No, it's not. We just do the next path and then.
Well, that's the
searching.
brute force solution, though, isn't it? Right?
Yeah.
So here, let's think of some of the data structures that we might need. So we need to keep a list of visited nodes, I think, right? Or like, let's say excluded nodes potentially. So
Yeah.
because the way that this will work basically is like if there's a node in the graph that is obviously not going to give us any better performance than the baseline, then that node should just immediately be taken out, right? And so I think this problem is more like you go through, and then every time you hit somewhere where you're like your minimum is going to be less than your baseline, and you just say add that node to
to the list of
a set of nodes that are excluded, and then what you're doing is every time you do your next traversal, if that node that you were going to traverse to is in your excluded list, then you just don't do it and you go to the next one instead.
It's standard in graph search, to have a list of visited nodes.
Yeah, a set of visited nodes.
Visited nodes, yeah.
And I guess you could use the index, right, for that. So the I comma j.
Yeah.
I like the excluded nodes thing. So how are we gonna?
So we need two things, right? We need backtracking. So we like.
Is that the way we're gonna go with backtracking then?
I mean, okay, right. So like, let's say in each position in the loop, right, we're at a specific node, right?
Yeah.
And then what we need to do is then we go to then each time we visit a node, we update our values, right? And then if those values, when they get updated, they now are like, actually that's worse than our best case scenario, then we need to backtrack, right? We need to go back to the previous where we came. So I guess we need to keep track of where we came from, right?
Yep.
So what? Yeah, that does seem.
Yeah, and then in each loop, what we're doing is we're checking, right, the current thing, and then if the next node is already been excluded, then don't go. So you've got left or right to choose from.
Yeah.
We need to keep track of the current node.
Yeah.
We're on.
And then and previous node, right? If both of the next nodes are excluded, then so maybe the best way to do this is actually in a while loop. And in each loop iteration, you are updating the indexes, right? So you store a reference to the previous node that you came from. And then depending on whether your next node or your current node is like better or not worse, let's call it, than your minimum, then you keep going until you reach. So that's how I think that's probably what we need. So not a for loop, but like you do a while loop and you keep going until you've exhausted all your nodes, I guess. All your potential paths.
Right. That's right. That's how these algorithms work generally.
So I guess you could do like current node. Do you have tuples in Golang?
Yeah, I think so.
No.
No?
Don't think so.
Yeah, that's fine. And then while I don't know what the condition should be right now. Let's just do while true, right? And then build this up slowly.
So you could make it a struct. That you could do.
Struct of 2. Yeah.
So,
Yeah, right. Okay.
that.
Right, so you've got your, let's say, baseline, right, is this, yeah. And then you have current health. So you do the same structs, right? Min health, but and then while true, so you say if maybe you need the i's and the j's.
Can you do that kind of destructuring? Or...
So if dungeon I
okay.
j, right? So let's say we visit this. And he was saying min health.
Thank you, Mark.
Plus
You've
equals.
made a note.
Oh, do you want to do it that way? Okay. Yeah, fair enough.
I thought it was easier.
Yeah,
I
that's
have
fair.
it either way. You suggested creating a couple, so I thought just create it. Like, whatever's easiest.
Well, I suppose if we're doing I's and J's, then it probably doesn't. It's not needed.
It's been a while in Go. No, there isn't.
You
have to do 4.
Yeah, you do 4.
Or something 4 conditions.
Yeah.
Just do 4 true. Okay, fair enough. Yeah.
Yeah, that works.
Expecting to return something.
So let's say we end. So like at position 2 or at position 0, what we want to do is say our current health, right? So we need the same sort of constructs, right? And then do if min health less than current health, right? Min health equals current health. And then here we also need like a check if min health is less than baseline. If so, add node to exclusion list, right? So if
could we not do that first?
Suppose you could.
Could you do something like, instead of having current health plus equals, could you not do something like cell something? I can't think of a good word for it at the moment. Like cell damage equals dungeon IJ. Then if cell health greater than baseline. Does that make sense? So like, before you do anything, are you about to completely obliterate the baseline? Are you going to go beyond the baseline? To say you've got
I think
10.
I think it probably doesn't really matter.
Okay.
I would say. So
Cool, that's fine.
Yeah. So like I get where you're going with this, but I don't know, just maybe it would make it like ever so slightly more efficient. I don't know. Doesn't matter, right?
No, it was just kind of.
But
optimization.
So here say like if min health is less than baseline, then okay, so we need a exclusion list. How do you do a set in?
The other issue is baseline is going to be a positive number at this point, and min health is going to be a negative number because we're.
Okay,
that makes sense.
Minus baseline -1. There we go. Easy. Or here, do it like this, right? If minus baseline -1.
Yeah.
Yeah, that kind of.
I know it's weird, but it's just because we did this to get the the test passing. Okay. So what we want is excluded nodes, right? It's going to be some kind of a map is the only thing that we can do, right? It's going to be a map of what?
You could make it an array. If we're storing nodes, you could make it an array of node. So that would be like.
Oh, I suppose you could literally just
Yeah.
have an array of like ones and zeros, right? And then you have
But we
if
have
Yeah.
right. So excluded
we have
nodes
no.
is just the exact same as dungeon, except we put ones and we initialize it all to zeros, and then if we exclude the node, then that yeah, I'll just do that.
Yep.
Is there a way that you can like create a so basically this should be a burpa int or boolean even, let's call it that, which is the same shape as dungeon.
Oh, we'll see, and the ones that are excluded will be a 1.
So there. No, that's going to need. I
On
suppose
the
you could do
other,
something like.
if you
Yeah,
make
you
it a
do the
list
make,
of
and then you say yeah,
Okay.
len dungeon and len dungeon 0, right?
yeah, but then what's the calculation you need to do to check if your node is in the excluded list?
You just say if excluded nodes bam bam
Hmm.
ij like that. That's it.
Yeah, but if it was an array of nodes, you could just check whether the node was in the list of nodes. Can you, Mark? I mean,
That's
if it
why
was a-
I don't see how
Yep.
that's more efficient.
Invalid.
Like, because an array lookup is 01, isn't it?
Yeah, I mean, yeah, it's probably more efficient, just like easier to think of for me. Okay, so what's wrong with that?
Is this not the?
Yeah.
Must be the expression.
Why doesn't that work? Invalid array bound must be a constant expression. Is this where you need make? We're not gonna get very far with this.
I mean,
We're not, are we?
Yeah, well, it's obviously not going to work with Lane.
No.
Yeah, there is.
So you want to make an
in Go, you can't do this. You have to do this bullshit.
Okay.
Then dungeon, right, and then dungeon 0. So you would do it.
So what are you doing here? Setting them.
Yeah. So it's.
Yeah, you basically
Bool
AI
to-
equals make bool.
That's right. 13, line 13 can now go. Yeah.
Yeah, so the A is excluded node, isn't it?
Yeah.
Yeah.
So let me just
Let's
refactor
just
that.
rename that.
Oh, it's horrible. I had a feeling it would be a bit of a faff in Go to do this
Yeah.
sort of thing.
Do refactor. There
But
you
then
go.
what you also have to do is set all of them to false, because I don't know what they start out as. Do they start out as false?
I
do
think
this.
default is false for a
Yeah,
bool.
okay. Okay.
Should we get rid of the comments? Don't
Yeah,
need
we
those
don't
now,
need
do we?
Okay. We probably don't actually need current node, to be honest, because if we're just
Okay, cool.
saying
Let's get rid of them.
like the I and J represent our current position in the grid, right?
Yeah.
For each loop. So actually, what we would probably want to do here, right, is say when we enter a node, we want to check if that node is part of the excluded node list, and then if it is, we want to go back to the previous node, right, and then run the same iteration again. But how do we know where the previous node was? Ooh.
Are we going to
Keep track of the previous node.
keep track of previous node, or are we going to do something like calculate?
Sure, but like so let's say this, right? Like we have all right, so previous node is
Colon equals.
yeah, previous I, previous J, potentially.
Yeah.
Yeah.
But why is that?
But you could set that at
It depends which direction you've moved.
Yeah.
That's the problem.
You could. Could you set that not in this? Like,
Yeah, you can do. If you move those out and make them start with 0, 0.
Yeah, start with 0. Yeah.
And then do last thing you do is previous J. You know, why didn't oh right, yeah, thank you. Previous I equals I J equals Z. That's probably the easiest way to do it. And then you have to also do that.
And then you set I
as well.
And then you have to decide where to go next.
Yeah.
Right?
Yeah.
Right, and that's based on whether it's in the excluded list or the next one's in the...
Okay, so maybe we should check, rather than checking the current node if it's in the excluded list, we should check the next node if it's in the excluded list.
Yeah.
Okay, yeah.
So only even move to a node if it's...
Yeah.
And you have two options, or depending on where you are.
So at any... What do you want to do? So each time you visit a node, you update this stuff, right? And then you decide whether the current node should go into the excluded list. And then after all that, then you have to decide where to go next. Now where to go next is either left, right, or back, where you came from.
Yeah.
But the problem is, let's say you've got, like, let's say you have to backtrack multiple times, right? Because you've gone down a route and it's like actually all the nodes around it now are part of the exclusion list. So you have to go all the way back. Like that is more like a recursion problem, I think. Because like how do you, once you've updated previous I and J and then you need to go back 2, then you're just going to keep on going back to the same point, if that makes sense.
Yeah, well, if that is a visited node, you need to go back further.
Yeah, but how do you know where you came from?
Last unvisited. Yeah, well, every time you go back, you need to check to see if there's an unvisited node next to you. And if there isn't, you go back again until there aren't any more nodes.
So how do we do that?
How do we... We're not incrementing the I's and J's yet.
No.
Or I suppose
No, near that.
what you could do is create like a linked list of what your current path is.
We're just an array,
But yeah,
so that you
so
know.
that's exactly what I mean, right? But like, so the array grows, and then each position tells you the where you came from, so that you can backtrack correctly.
Yeah.
But that feels that feels like, is that the right approach?
So that's I was trying to work out. I don't think it'd be efficient, but an easier way to like think about it for me is: could you build an array of all possible paths first? Get your baseline out of it by the first path you build would be that all the way to the right, all the way down. So that would be the first thing you do.
So what you mean like an array that looks something like, well, like right, down, that kind of thing.
Yeah.
And then you have another one which is like right down type of thing.
Yeah, or whatever it is.
I can
Calculate all the possible options. But then what I'm trying to work out is we're looking at this excluded node thing, right? You could. This is where the problem is like it's very easy to reason. It's massively inefficient because what you could then do is have a way of removing any path. As you hit an excluded node, you just remove everything from the path. It's the problem, isn't it? It's like it would work. It would not be efficient.
Yeah, exactly.
Well,
Right? And that's why, because like you could literally start, go back to the start and then go. I suppose we could do that, right? So we could just do go back to start and go again.
Yeah.
I mean, we still have some form of early termination because
So
the excluded
I
node.
actually know that maybe this would work, right? So you could just keep on doing like start from the beginning and then keep on going until you hit an excluded node. So like if your next one left or right, right or down would be excluded node, then you go start again from like put the current node into the excluded list, and then go back to the beginning and go again. That would work.
Yeah.
That's what Mark initially suggested, but I think that's more inefficient than just going back to the last.
Yeah, but the problem is if you wanted to go back to the previous one, you'd need to do it we'd need to do it recursively. That's the only way of doing it.
No, not necessarily.
No, it is.
Like you keep a list of.
Oh, or you store a list of where you came from.
Yeah.
Yeah.
Yeah, we could do that. It's a lot of data structures to manage.
Yeah.
Yeah, I would say, do the list of current paths or something.
Yeah, okay. And then how do we want to store that?
So is that list of nodes? We've gotten rid of nodes already.
You could make each element tuple, a 2D. You can make each element an array of 2 elements, right? Where it's the I and J. So
yes, an array of.
So it looks something like. Excuse me. you mind if I type for a second? So it looks like this, right? Yeah, at each point, basically. Like that's what it'll end up looking like. And then when you want to backtrack, you pop off the end of the array, right?
So this would be fixed at 2.
Yeah, the second element would be fixed at 2. That could grow to whatever.
Yeah. So it starts with an empty array. It's
yeah.
And
then we don't need this, and we just say every time we enter the loop, we will have changed positions somewhere, right? Like we will
the
have
first is
entered a new position.
ij. I mean, it'll always start with 0, 0, won't it? Anyway.
Yeah. So then you say current path. You need to add.
Yeah. How do you add to an array?
But
a list. Append, right?
Yeah.
And no, that doesn't work. And
no, so you do this current path equals append, like that. It's it updates it. It doesn't update it in place.
Oh, right.
Right. So yeah, we add it to the and then if the current node is excluded, then what we want to do is current path dot basically delete the last element, pop the last element off. Is that a thing? Can you do pop?
Yeah. Do you want me to do that?
Yeah.
Mark, why doesn't it like this ij?
Just trying to work that out. Hang on.
Is it because it needs to be a struct or something?
Is it this?
Yeah.
Ah, right.
And you set the size to.
Yeah, there we go.
I think.
So if it is, you pop off the current node, right, and then you update your I and j.
Okay, cool.
To be the previous one, right?
So you can do that. This is where it becomes fun.
Yeah.
So you do pop off the last one. You can do this. Ready? So current path. Brackets.
So the problem with this is we're going to get into an infinite loop here because we're just going to keep on hopping back and forth because we need to look at the next node basically before we decide to visit it. Like if next node is excluded, then don't visit it, right? Rather than checking if the current node is excluded, then go back. So what you do is if excluded nodes
Is that
if,
what?
So this would be, it probably wouldn't put this at the start of the loop, if that makes sense. So this would need to go at the end. So like so once you've done all your updates at the end, then say, right, where's the next node I go to? Yeah. Is where you check is down excluded, is right excluded.
Yeah.
By default you just say I'll go right first, and if that's excluded, then I'll go down instead, and if both are excluded, then I backtrack, right? So
Yeah.
this comes here at the end, right? So we say check if right node is excluded. So if excluded nodes I plus 1, right? We're gonna definitely have to do a check to make sure that we're not reaching the end of the list. Sorry, be this one. So check if we are at the end of the row. If j plus 1, or rather if j equals len dungeon minus 1,
dungeon 0 if you're doing the row,
then no right node to check, right?
Wouldn't this be dungeon 0 though?
Yes.
Yes, and then the other one is
Yeah, and
obviously.
then
Yeah.
check if we are at the bottom of the column, right? If I len dungeon minus 1, then no down node to check.
Yeah.
Otherwise we check both, right? And what we could probably do is create 2 subfunctions for this, right? So like check, oh, don't have to necessarily, it would just be easier to read, right? So check left, sorry, check down node. So if excluded nodes I plus 1 j ooh, this isn't gonna work because we have to check both. Because like if we're at the end, well, we'll have to have a check like if we're at the end of the array, basically.
But if it doesn't have that many elements, it's gonna throw an exception.
Anyway, we can do that just before. So if we have a down node to check, then we'll say if I feel like I'm doing this the wrong way. There's gonna be like a lot of duplication in here, but if the next node down is taken, then backtrack, right? So then we say I j equals current path dot basically this, right? Like that's what it needs to be, and we need to pop off the last element of it, or we need to
Oh, minus 1. It's just a
yeah,
node.
but the problem is because we've appended the current node to the current path, right? We'd have to pop that off. Alternatively, we could append it afterwards, right? So we don't have to append it at the top, but we can append it like if we decide to not backtrack, then we append it, right? If that makes sense.
That makes sense.
Right.
Kind of stay where you are until you're happy.
Yeah, exactly. So I and j basically become your previous, like the last element of the current path. And then you backtrack, and then you have to pop, right? And then
There's not a pop
the
function.
next loop.
can-
I know, but however we do that.
Yeah.
Right?
Oh,
And
right.
then-
Sorry.
and then
Yeah.
you-
Yeah.
And then
Sorry.
you do next loop iteration, right? I'm just thinking of the logic here, right? We can always convert it into code after. All right, go to next loop iteration. Is that just break? Yeah. Or continue? Continue. Yeah.
Continue. Yeah.
So we've got about 10 minutes left.
Yeah, I don't think we're going to get through this. We've not done very well.
No, we're not. No.
No, shall we do
Do you
reflection?
want to do a bit of a retro? Do you want to do a Splat Tab Mad or just have a bit of a chat?
I think just have a little bit of a chat about it.
Okay.
Sure.
So
Right.
maybe picking a really hard Leetcode as a start might have been a bit too ambitious.
Optimistic? Ambitious, that's the word.
Yeah, ambitious.
Yeah.
We would definitely have failed the getting hired at Google test.
Yeah, we definitely have. Yeah.
I mean,
And we've done that publicly, so
Yeah, I know.
well done, everyone.
So
we never
don't
get to
hire us.
Google. I sitting here and it only dawned on me in about the last 10 minutes is we should have probably spent more time at the whiteboard
Yeah.
because
Yeah.
we should have gone back to the whiteboard one and worked out how we were going to do our maneuvering round and just drawn that out.
Yeah.
Like how are we going to this is our first path, okay, the second path and stuff like that, because
yeah.
we maybe attacked the wrong problem first of looking at health points. Our first thing we should have probably thought about was what are we going to do to maneuver ourselves through the various paths.
Yeah.
I think, yeah. I mean, I think though. I mean, I enjoyed doing it as a thing, and I think we came up with the principles of what we wanted to do. Is in our realizing, we should backtrack and we can do this, and you can do this early termination thing. I think that was all solid. I mean, I don't know. I haven't seen a solution for this. Maybe there's a much nicer way of doing it, but that seemed good.
About halfway through, I was going to say, let's just write it really inefficiently and throw some Go routines in.
Yeah, but
That's always the answer,
this is
isn't
the
it?
thing about like algorithm problems, right? It's like, yeah, the brute force solution pretty much anyone can come up with, but that's not the challenge,
Yeah.
right?
No.
But yeah, I agree with you, Rory. I think we're probably on the right track unless we're missing something super obvious. It's just then the implementation of like, okay, how do you actually put that together?
I'm also, it occurs to me that like if you are trying to solve an algorithmic problem in the most efficient way, TDDs is going to get in the way.
Yeah, I mean,
Yeah.
But there's still a problem because you have to have something to test it against.
Well,
Otherwise, how do you know it works? I mean, you've written extremely complex code. How do you know any of this works?
Because you're Leet.
I mean, the answer is kind of. It's not a good. I mean, the way Leetcode as a website does it is you have these kind of like a handful of normal tests, and then when you submit your problem, it throws like 100, some of which will be quite large. And if you hit a certain, if it takes too long or it hits some performance thing, it will just reject your solution.
Yeah.
And
Right.
also, it will tell you how you are for the language, like you're in the top 30% or you're in the top 50% compared to other people, your solution.
so it's
In
like,
terms of time, the time that it takes.
yeah,
Yes, the time and memory usage. So,
Right.
which is a very different. It's not a. It's a performance based. Yes, you have to give the
You could
correct
write
solution, but
performance-based tests for it.
performance testing.
Yeah. I suppose here's an interesting. Did everyone enjoy it?
yeah. It's so for me, I think it's like it's a different development process to what you would normally do, right? Because like a lot
Yeah.
of what we write is not this kind of stuff, right? It's like
No.
the algorithms themselves are like super simple, and a lot of it is more like behavior, and TDD, whereas this is the opposite of that, right? It's like you have some real difficult problem to solve where, okay, yeah, you can TDD it, but you have like the one test for it, which we did, but the actual getting to the answer is incredibly difficult.
Yeah.
Yeah. I'd be curious to know, because this is the classic, like, you do an algorithmic interview problem. You revise algorithms, and then you get into a job and you never really use it again. So I'd be curious, or very rarely use it. And if you do, it's often sort of, you can import something to do it for you.
Yeah.
You just look it up.
Yeah. So I think it depends. You're absolutely right. I think it nowadays, especially like software engineering is a lot more abstract than like, find the maximum number or implement a sorting algorithm, right? Like,
it's more abstraction. But I think, a lot of these LEET problems, at least partially, they seem to be solved problems where if you need to pick the right algorithm.
Yes.
And there's probably a known algorithm that does this.
Yeah.
Oh, yes, sure.
Well, I mean, why shouldn't you use that would that pass if you used a known algorithm as part of the solution? Would that pass the LEET test?
So I think where it's coming from is
The
more
library.
Is more like, yeah, for most problems you can look up like this is the solution for it, but for like, think about the companies that use these tests, right? Like, they're always coming up against the novel things that haven't been solved yet, generally.
Yeah.
Especially if you look at AI and things like that, right? So it's still useful having like the skills to be able to like break down a data structures and algorithms problem and be like, right, how do I solve this really difficult thing?
Is that really true, or is it more your algorithms well enough, you go, I know I will use a depth first solution here, and this is the sort of one to use? Is it more, I'm not saying pattern recognition, but you know what I mean? Like, it's more, it's unlikely you're going to
exactly.
No, I agree with you, but that's what I mean. Like, having
you recognize a known algorithm, you say this is Dijkstra's algorithm or whatever.
Yeah, but it's having the familiarity, right? It's like why do we do code katas, right? And like, to practice TDD, because there's also patterns in TDD that we employ. But yeah, I enjoy this kind of stuff because it is like, this is real. It feels like a different kind of problem solving, if that makes sense.
Yeah, it does. It felt like it was exercising a completely different area of my brain.
Yeah,
to
that's what I was gonna say.
What I'm doing on a day-to-day business, and I really enjoyed it. And I've generally kept away from like Leetcode challenges and stuff. And actually, maybe I won't start on the hard ones next time. But I am interested in like going back and going, like, this is stuff like I did at university a lot, and it was really fun. And then you get to work and you don't do it a lot, so you don't think about it. And actually, I want to put myself into a headspace where I do think about this sort of thing.
Yeah, no, same for me. Like, this has been a very humbling exercise for me, and now I'm like, right, as part of doing katas, I'll also start doing Leetcode problems every now and then, just to build familiarity back up with these sorts of problems.
Mm.
I mean, in some ways, it has been humbling, but I didn't do a computer science degree, so I don't do algorithms. So my only thing here is like reading up a bit on this stuff. And I say that between the four of us, I think we are, not our pure code, but our pseudocode, it seems logical to me. Maybe we're missing something, but our pseudocode of, we do this, we have a baseline, we do this early termination, we step back, seems like the right approach. And we haven't quite got are we going to use recursion here, or what's the exact structure? But the pseudocode thing, I felt quite encouraged that it made sense to me.
Yeah.
We certainly get points for using the right approach.
Yeah.
If there's people watching this and they're like, you guys are idiots, like, this is such a simple thing and you've gone down with completely the wrong way. Please let us know.
No one's commented on the chat on this one. I don't know if anyone's actually even watching. I can
Yeah.
only see the chat, not the people watching. But yeah,
if we're gonna do this again next week, let's do a medium one. Not
an
like
easy.
crazy difficult. Yeah. Just to be like, right, maybe we should practice a little bit. Just because we. Yeah. It's been a while since I've done a proper algorithms problem like this, like years.
Yeah. No, I'll be up for doing one of these again.
Yeah.
Yeah, everyone else will be.
Yeah. It would be nice.
Cool. Yeah. Maybe not in Go.
I feel like Go is a little bit irritating with this. Just because of like the faff, how much you have to faff around with some of the syntax.
Would be a lot easier, no?
But I mean, hey, if you did it in C, I think you'd probably have similar.
Oh, C would be even worse.
Bigger issues. But yeah, I think. I mean, I'm game for doing stuff like this in Python, just because it's easy to get a lot of stuff done, and because, we're talking about, I think our pseudocode is right, and then the challenge here is just like, how do you turn it into Go syntax?
Yeah.
Because 90% of the time you're spending in like diagramming and like how are you actually going to solve this problem? Yeah.
Cool.
And then yeah, let's do more diagramming next time and actually figure out like the solution on a whiteboard first.
Yeah.
And
because even if we could have just drawn up, okay, path 1 is this path, path 2 is this path. So at least you had that in your head rather than trying to do it in code straight off.
Yeah.
So, or what does backing up look like and stuff like that. Cool.
Thanks all.
Thanks. This has been